In section 11.7, we're going to talk about chords and arcs. So we've been talking a lot about arcs related to their angle measures, and we mentioned a chord earlier in this chapter. In a circle, if a diameter or radius is perpendicular to a chord, then the chord and its arc are bisected. So if we have a chord right here on our circle, remember all a chord is a line that connects 2 points on a circle, and it doesn't have to go through the center like a diameter does. So if we have a diameter or a radius, so let's draw, we have the center of our circle, we have a radius going from the center to the edge of our circle. If it is perpendicular to our chord, that means this angle right here is 90 degrees, then the chord and its arc are bisected. So that means that this side and this side of my chord are the same, and these two arc segments are the same. So if we have our example, AB, our line is our chord, CD, call these points C and D, is our radius. Then we know that AM, let's call this M since it's our midpoint, segment AM is equal to MB, and arc AD is equal to arc DB. And we can make these symbols our congruent symbols. They are congruent. Okay, so that is our rule for our radius bisecting our chord. So if we look at an example of that, this says find the indicated measures. So first we need to put some more information, some more given information on here. So this is our center, and our diameter is AB. Got a C in the middle. Call this point Q. We know it is perpendicular. This segment is 12, and this arc is 30 degrees. And we're actually just going to scribble this top one off. We already know. Sorry, this isn't Q, it's G. Okay. So this is what we're looking for. So if we have GM as our first segment, we want to figure out what that is. We know this one over here is 12, and since this is perpendicular to the chord, we know that this one is going to be the same thing, 12. Our segment PM, all the way across that chord, if both pieces are 12, we can add those together and we get 24. Then our arc PB, that is already given information, that is 30 degrees. But if we know that that arc here is congruent to this arc here, arc MB, then that is also going to be 30 degrees. And then if we want to find the whole arc, PM, we can add both those pieces together. 30 plus 30 gives me 60 degrees. Okay? Alright, our next example says that suppose a chord is 24 centimeters long and is 9 centimeters from the center of a circle. So let's draw that out. We have our center of our circle, and we have a chord. Chord goes from 2 points on our circle, not through the center, because we know it is 9 centimeters from the center, and our chord is 24 centimeters long. We want to find the length of the radius. Well, if we know that our radius is the distance from the center to the outside of our circle, and if our distance from the chord to the center is 9, the shortest distance, that makes this right here a right angle. If that's a right angle, we know that our two segments of our chord here are equal. Well, if the whole thing is 24, we got to divide that 24 into two equal pieces. That makes each side here 12. So now, if you look here, I have a right triangle where my two legs, I have a leg of 9 and a leg of 12. And I'm trying to find my radius, r here. So I'm going to use my Pythagorean theorem for a right triangle. A squared plus b squared equals c squared. In this case, my a is 9, my b is 12, and my c is my radius, my unknown. So if I have 9 squared, that gives me 81. 12 squared is 144. 81 plus 144 is 225. Now to get that r by itself, I need to take the square root of both sides. Square root of 225 is 15. And that leaves my radius is equal to 15. Okay, so the important thing to do in these word problems is to draw out the problem first. Okay, so let's move down to number 2. I'm going to draw a circle here. So if we have our circle, and it says, suppose a chord is 10 inches long and is drawn across a circle whose radius is 12 inches long. How far is it from the center? So we have, first of all, a chord that is 10 inches long. It is drawn across the circle, and our radius of the circle, we draw our radius again, it is 12 inches long. How far is it away from the center? So we have a similar drawing to above, but this time we want to figure out what this distance is, x. Again, we know that this is 90 degrees, this is going to split into two equal pieces, so that means both of these are going to be 5. And again, we have a right triangle, so we can use our Pythagorean theorem to figure out what that x is. In this case, my a is x, my b is 5, and my c is 12. 5 squared is 25. 12 squared is 144. Subtract 25 from both sides. X squared equals 119. To get x by itself, I take the square root of both sides. And that leaves me with x equals 10.9 inches.